Hello everyone. Today we are going to start a new project on forest detection by using UNet and image segmentation in deep learning. Let's see. This is the image of the forest taken from the satellite view. See this also. Okay. Before this, I will show you how we built application for this model so you can come to know our application model how it look like. See, this is the outlook for our application model. Inside this, see this ROI segmentation. Welcome to ROI segmentation. This application uses advanced segmentation techniques to identify regions of interest in your images. Start by uploading an image. Click on it, go to upload page. It will open the next page. Inside this, you will see this upload an image for segmentation. Please select an image to process with our segmentation model. Choose the file. By choosing the file, it will choose a image, then it will detect and it will give a resultant as a output. Okay, by I am choosing on file. Now upload and process. Clicking on it, it will upload and proceed. See, this background code is running inside this essays. Okay. Yeah, you got an result of segmentation output. Inside this input image, we given as a input image. Hey, predicted mask. See this predicted mask and overlap image. See this white shaded area is forest, and here is a red shaded area. Okay. Okay. Now coming to the our research paper. We took an research paper for this model which look like this. Inside this research paper, satellite based forest stands detection using artificial intelligence. See this research papers contains like this: literature review, performance metrics, calculation, methodology of data collection process and cheating dataset, and tables they have mentioned, analysis of identification limitation, and this the pictures of this some examples of forest from taken from the satellite view. Okay, and this is the class division graph and some matrix, confusion matrix also they given. Also YOLO weight with the dataset forest and confusion matrix also they given for different results. And these are the accuracy mask RCNN models with backbone ResNet. Okay, these are the images they have taken. Now coming to the explanation of this research paper, we took some key highlights for this research paper so you can come to understand for air easily. These are the importance of the forest detection from the satellite. See this forest health monitoring. From this model we can come to know disease and pest detection. Satellite can identify unusual changes in canopy color or density, indicating insect infestation or plant diseases. Drought stress observation. Vegetation indicates like NDVI from satellite data reveal water stress before it becomes visible to the human eyes. Deforestation and illegal logging detection. Real-time alerts. Satellite images allow quick detection of illegal clearing activities. Global coverage. Remote sensing provides consistent monitoring over vast and inaccessible forest regions. Climate change mitigation. Carbon stock estimation. Forest act as carbon sinks and satellite data helps calculating biomass and carbon storage. Emission tracking. Identifying forest loss helps track greenhouse gas emission. Biodiversity and wildlife habitat protection. Habitat mapping. Satellite data helps locate and protect areas crucial for endangered species. Fragmentation analysis detect how roads, satellite settlements, or agriculture breaks up continuous forest areas. Disaster management, forest fire monitoring, satellite detect hotspots and fire spread in near real time. Storm damage assessment, after cyclones or storms, imaginary can quickly quantify at affected areas. Sustainable forest management. Logging planning supports controlled harvesting while preserving ecological balance. Reforestation tracking. Monitoring progress of tree planting initiatives over time. Policy and decision support. Evidence for enhancement provides usual proof for legal action against illegal deforestation. Planning conservation zones support governments in designating protected areas. Now coming to the research paper, some key highlights I have taken we did for this. Okay, introduction from this research paper. Forests are one of the most vital ecosystem on our planet. They produce the oxygen we breathe, store carbon, and support biodiversity. But monitoring them manually is slow, expensive, and sometimes impossible in remote regions. This project includes an AI-powered approach for detecting forest stands using high-resolution satellite imagery and deep learning models. Now, coming to the dataset they use, they created custom dataset from high-quality satellite images sourced from the platform satellite.pro at a zoom level of 20 meters. Each screenshot Originally, originally 876 by 879 pixels was split into four smaller images from consistency, resulting in uniform crops of 438 by 369 pixels. The dataset covers five classes: forest, field, lake, road, and building, and including both urban and rural landscapes. Annotation was done using roboflow.com with instance segmentation, enabling pixel level precision in labeling. Two versions of the datasets were prepared. Version 1, called Forest Full V1, contained about 4000 original images, augmentation to 9800 for training, 600 for validation, and 200 for testing. Version 2, Forest Full V2, was expanded to a 5100 original images, enhanced enhanced with more roads and building to balance the classes, and augmented to over 11,900 training samples. Processing for this research paper, they applied multiple pre-processing steps to improve model performance. Images were cropped and resized for consistency, then augmented using horizontal and vertical flips. Colors saturation changes up to plus or minus 30 percentage, and brightness augmentation adjusted up plus or minus 25 percentage. This diversity helps the model generalize better in real world conditions. Models they used evaluated three stages of art deep learning architectures. First, YOLO 8 tested in both nano and small variation known for its speed and high accuracy in object detection and segmentation. Second one is YOLO 5, also tested in nano and small configuration for performance configuration. And third one is mask RCNN using ResNet 50 and ResNet 101 backbones are a well-known choice for pixel precision segmentation. All models use instance segmentation, provide detailed mask for each detection object rather than just bounding boxes. Classification approaches inside this, they primarily targeted was the first forest classes, but they also classified four other land cover types: field, lake, road, and buildings. Evaluating Evaluation was based on precision, recall, F1 score, and overall accuracy. They also experimented with different batches sizes 4 to 16 to study their effect on the training quality and class precision, accuracy, and losses. The best performing model was the YOLO 8 was small and trained this forest full V2 dataset with a batch size of 4. This model achieved 93% precision for forest, 91% for field, 85% for building, 94% for lake, 86% for road. They tested on 48 unlabeled images which contained correctly identified 44, achieving a overall of 91.67%. Proposed system proposed system overall overflow. The proposed system works in three steps. First, input satellite images are proposed and formatted for segmented. Second, the trained YOLO 8 small model detects and segments objects into one the five classes. Finally, the system outputs segmented images showing precise boundaries of forest, fields, lakes, roads, and buildings. This automated pipeline can be integrated into real-time monitoring tools, helping forest management managers detect for deforestation, track changes, and plan conservation efforts. Application for this research paper they have given. This technology has real world application in forest conservation, deformation monitoring, wildfire impact assessment, urban planning, and land use classification. Conclusion of this research paper: by combining high resolution satellite imagery, balanced dataset, and advanced AI models like YOLOVATE, they have developed a powerful system for forest and stand detection. Its speed, precision, and adaptability make it a valuable tool for environment researchers, policymaker, policymakers, and forest management teams worldwide. Okay. Now coming to the our model, okay, I'll show you some code of some important code for this model, so you can come to know how we built for this model. See this, these are the codes. Okay, inside this we did some augmentation, image formattation, everything we did. Then we given the result, and we did 15 epoxes for this model. For demo purpose only, we did small type of epoxes. Okay, for inside this loss of 0.5878, accuracy of 0.6976, and see this validate loss of 0.5181 and validate accuracy of 0.754. After that, we final epox of 15th epox we got an result of loss of 0.4050, accuracy of 0.8150, and validate loss of 0.4274, validate accuracy of 0.8108. In 15 epoxes, we got a validate accuracy of 0.8108. If you did and 500 epox, then you will get at approximately of 90 above percentage, we will get the accuracy. Okay, for demo purpose, we did only 15 epoxes, and this is the input images C and predicted mass and ground truth. This see this reason, this only reason is forest area from the satellite view. See this white area, this is the predicted mass and ground truth of this. Okay, now coming to the application part, which was already explained. Once again I will show you image. Okay, so you can come to know the our application model. See this code is running inside this command prompt. Okay, welcome to the ROI segmentation. This application uses advanced segmentation techniques to identify regions of interest in your images. Start by uploading an image. Okay, go to the upload image page. Okay, upload an image for segmentation. Please select an image to process with our segmentation model. So choose file. Okay, choosing file. Then choosing by the file, it will upload inside it, and then it will give an result as output. Okay. Okay, uploading. Now upload and proceed. Then we will get the result. Guys, this is the unit unit and image segmentation. Okay, code. Image input image like this, and predicted mask is like this. White area is shown. No, this is the forest area, and this is the red area, red or overlapped. Okay, image which is indicated by red. Okay, now this is the our I select process another image. Let's see another on the image. Okay, choose the file. Now select this one. Okay, let's see result how it will get. See this, we got the result. Okay, this this is the forest area. Okay, okay, another one we can see. Let's see, and we finish it up. First one. Okay, see, we got this result. Okay, okay. Now, guys, if you like this model and project, you can share with your friends and help to them to know our model. And also, if you need any help regarding this model, you can contact us through our channel, which there we provided our contact number. Okay, thank you guys for watching this video.